Hello, I am Mrs. O'Brien. In this video, we'll go over the solutions to homework problems from section 12.6. On question number 3, we have a large running track that's constructed to have straight sections, which are here, and two semicircular sections, so each one is a half a circle. I drew these gray lines in, so that would be easier to see. Assume that the runners always run on the inside line of their lane. A race consists of one full counterclockwise revolution around the track, plus an extra portion of straight segment to end up at the finish line shown. What should the distance x between the two starting blocks be in order to make it a fair race? So in other words, they're going to start at different spots so that they both end up running the exact same amount and the finish line is the same for both of them. So this straightaway part is 100 meters no matter where you're running. So really that 200 meters of the track is not causing any change in where they need to start. So it's the circular part, whether they're running on the very inside lane or the inside of the outer lane. So if we look at these, we basically have two radii. We have the 40 meters if they're running on the inside of the interior track, and then 45 meters if they're running on the inside of the outer track. So since we're talking about the distance around a circular piece, we are talking about circumference. And when we put this half together with this half, it would be a whole circle. So the circumference is going to differ by exactly 10 pi. So if we were to find the circumference of the 40 meter, 40 is the radius, so the diameter would be 80. So that would be 80 pi for the circumference of that one. And 45 meters would mean we'd have 90 for the diameter. 90 times pi is 90 pi. So the difference between 90 pi and 80 pi is 10 pi. So that's where this x needs to come. You could have also found the exact distance around each of them. The inner track would have been 200 plus 80 pi. And then the outer track, so if they had run around the outside of the track, it would be 200 plus 90 pi. Again, the difference between these is 10 pi. That's just two different ways you could have looked at the problem. Question number 4 is a little bit trickier. Suppose you have a large spool used for winding rope. So you're winding the rope around the spool. Suppose the spool is 1 meter long and has a diameter of 20 centimeters and a total height of 60 centimeters. Well, first thing I notice is I have one in meters and one in centimeters. Approximately how long a piece of 5 centimeter thick rope can be wound onto the spool? So if we look at 1 meter, that's the same as 100 centimeters if we want to at least have everything in the same units. So a rope that is 5 centimeters thick, one layer, if I keep going around the whole thing, would be 20 winds, because 100 centimeters divided by 5 centimeters, because that's the thickness of the rope, gives me 20 winds. So again, the 100 centimeters divided by the 5 centimeter thick rope would give us 20 winds to cover once over the spool. Each wind is going to use 20 pi of the rope, or 20 times pi. And the reason is this is the radius rate, or sorry, the diameter right here is 20. And to find circumference, we go 20 times pi. So that's where the 20 pi is coming from. So that's the length of the rope at each wind to go around. So 20 winds times 20 pi gives me 400 pi centimeters for the one layer I'm going to get across. So this green would be the first layer of rope. And since the rope is 5 centimeters thick, with the purple I've kind of shown this next layer is going to have 5 centimeters above, inside 5 centimeters below, giving us a diameter of 30 centimeters for the second layer. I'm still going to have 20 winds across, so the second layer will use 20 times 30 pi. Again, that's the circumference, of 30 multiplied by pi is the circumference of one surround times 20 lines, giving me a total of 600 pi centimeters for the purple layer that would occur, or the second layer. This process is going to continue for each of these until I run out of room. So 20 lines times each of those circumferences per wind, and I would get 20 times 200 pi, or 400 pi, which is about 12,560 centimeters, or approximately 126 meters. Now, some people only go up to the 50 pi because they believe at that point it is full. I did show it up to 60 pi, but I would accept either answer. In question number 6, we're basically given a smaller pizza that's 12 inches in diameter, and we're told that this feeds 6 people. Using that information, we're supposed to figure out how much the 16-inch pizza will feed. So a 12-inch pizza has a radius of 6 inches. So if I was to find the area of this smaller pizza, it would be 36 square inches, because 6 squared times pi is 36 pi. If that serves 6 people, I divide by 6. It means each person is getting about an area of 6 pi square inches, or 18.84 square inches of pizza per serving. So we look at the 16-inch pizza. That would have a radius of 8 inches, and 8 squared times pi is 64 pi square inches. So that's giving us the area of the larger pizza. And we know that each serving should be 6 pi. So we divide by 6 pi. 64 pi divided by 6 pi is 10 2/3 servings. So it will feed between 10 and 11 people. Question number 7, the penguin question, has a lot of parts to it. Let's start by examining the global information. Penguins will huddle together to stay warm in very cold weather. If you've ever watched Happy Feet, you'll see this in the very beginning of the movie. Suppose that a certain type of penguin has a circular cross-section approximately 14 inches in diameter, so that when you look down on the penguin from above, the shape you would see is a circle with a diameter of about 14 inches. Suppose that a group of this type of penguins is huddling in a large circular cluster, and that has about 20 feet in diameter, meaning all the penguins are still standing upright on the ground. They're not piled on top of each other. They were standing straight up, and there's one big circle that has 20 feet in diameter. So one thing you'll notice is that each individual penguin is measured in inches, and the entire group is measured in feet. So if I use this information and find the radii of each of these circular areas, each penguin would have a radius of about 7 inches, and the large group of penguins would have a radius of about 10 feet. So question A says, assuming that the penguins are packed together tightly, estimate how many penguins are in this cluster. You might use areas to determine this, and is this going to be an overestimate or an underestimate, and explain. So for question A, the first thing I did was I figured out the area of each penguin, and it came out to be 49 times pi square inches, because the radii 7 squared multiplied by pi. And I left it in terms of pi, but if you wanted to, you could multiply by 3.14 instead of the pi. The large group of penguins had a diameter of 20 feet, so that means a radius of 10 feet. 10 squared is 100 times pi would give me 100 pi square feet for our large group of penguins. So if I know the area of one penguin and I know the area of the cluster of the penguins, I would like to divide. But they are not in the same units. One's in square inches and one is in square feet. So I'm going to take the 100 pi square feet and convert it to square inches, which I've done right here. 100 times pi square feet. I know there's 12 inches in 1 foot, and I do it twice because square feet is a two-dimensional measurement. So I need to use my linear conversions twice. That gives me 45,239 square inches, approximately. I would take this value, divide by 49 pi, and I would get 294 penguins. So about 294 penguins. Each penguin is approximately 49 pi square inches, and the large circle had an area of 100 pi. So again, if I switch everything to square inches and divide, you get about 294 penguins. This estimate is too high. because it doesn't account for all the gaps that exist between those penguins. But it's a good estimate. Question B, the coldest penguins in the cluster are those on the circumference or around the outer edge of the circle. Approximately how many of these cold penguins are there at any given time? So we know that the circumference of the large group of penguins has a diameter of 20, so its circumference would be 20 times pi. So the circumference of the large group is 20 pi feet. So I need to convert that to inches so that I can figure out how many are on the outside. So 20 pi feet times 12 inches in 1 foot give me 754 inches. So the circumference around the outer group of penguins is 754 inches. Now I know the diameter of every single penguin is approximately 14 inches. So 754 inches divided by 14 inches, which is the amount per penguin, would give me a total of 54 penguins. I probably should say inches per penguin there. Okay, so a total of 54 penguins around the outside. So that no penguin gets too cold, the penguins take turns being at the circumference, the outer edges of the large group. How many minutes per hour does each penguin spend at the circumference if each penguin spends the same amount of time at the circumference? So basically, no penguin wants to be there too long and get too cold, so we're trying to share that role on the outer edge equally. So we know that with 294 penguins and 54 spots around the circumference, we would say that there are 294 divided by 54 gives us about 5.4 penguins for each spot. And there's 60 minutes in an hour. So each penguin should spend about 11.11 minutes. So you take 60 minutes in an hour, divide by the 5.4 penguins, and that gives us 11 minutes per penguin. Thanks for watching. The images and questions from this video came from our textbook, Mathematics for Elementary Teachers with Activities.